Alright guys, today we are moving on to our third method for solving quadratic equations. So we've already talked about solving by graphing and solving by factoring. Today we're going to be solving by using square roots, which only works in some instances, not all, and we'll get more in depth about that in the next slide. But first it says, what do we know about square roots? So we know the first 12 perfect squares. So you should either have them memorized or be able to generate a list pretty quickly. But if I have 1 times 1, that's 1. 2 times 2 is 4, and so on. So you should be able to generate a list of your first 12 perfect squares pretty easily. So here they are. And it says we know how to use a calculator to approximate non-perfect squares. So anything that's not a perfect square or it's larger than it's in your list, we can use a TI-30 to calculate. So let me pull that up for us. So let's say I wanted the square root of 37 because that's not a perfect square. If I want to approximate that, I will do second this key. So the square root's right above. The one above it is where you would have like a cube root, a fourth root, but if you just want a square root, you want the one without the variable in front of it. So the square root of 37, when you hit enter, it gives you what we call exact form, but we want approximate form. So if you hit your toggle button, it'll give you the decimal. So we'd say it's approximately 6.1. And then the built-in calculator on your MacBook will also do these for you. So if you have the small version, you just click this green plus to get more options. And for the MacBook calculator, you would do 37, and then you want this key for square root. So 6.1 either way. We know that the square root of 0 is 0. We know that negative numbers have no real roots. That's because to get a negative number, I need one positive and one negative, but you can't do that for squaring and square roots. And it's not that they have no roots, but they have no what we call real roots. There are such thing as imaginary numbers, which you won't get into until pre-calculus if you choose to go that far in math. So don't worry about what imaginary numbers mean for now. Technically, negative numbers can have roots, but none of them are what we call real roots. So for our purposes, we would say there's no solution. And then we know that positive numbers have two roots. So for example, the square root of 25 has a root of 5 and negative 5. Or sometimes we'll write that as plus or minus 5 like this to write it in one chunk. But really we're talking about positive 5 and negative 5 because 5 times 5 equals 25. But negative 5 times negative 5 is also a positive 25. So if you're square rooting 0, you just have one root. If you're square rooting a negative, you'll have no roots. And then if you square root a positive, you have two roots. So our method for today, our third method, is using square roots. This method only works when b equals 0, meaning we don't have a middle term. We just have an a term and a c term. So since there is no middle term, there is not an x term, I can just solve this like a normal equation. So I'm going to move things away from my x and then square root at the very end to get rid of this square. So I'm going to treat it like a two-step at first, where I'm going to add 98 to both sides. And then divide by 2 on both sides. So I get x squared equals 49. My last step to do to get rid of that square is to square root. Squaring and square roots are opposites. So if I square root both sides, I end up with x equals positive and negative 7. So you can split it out where you have 7 and negative 7, or this would be the shortened version of that. We already talked about this briefly on the first slide, but we can have, for any of our methods, we can have 0, 1, or 2 solutions, 2 being the most common. But we already kind of talked about this. You would have 0 solutions if you're trying to take the square root of a negative. You would have 1 solution if you're trying to take the root of 0, because square root of 0 is only 0. There's no such thing as a positive or a negative 0. And then you'd have 2 solutions if you're taking the root of a positive number. Okay, so just some more examples we're going to run through. Hopefully we'll get the hang of this. Here, solving by square roots. I just have to do my last step of square rooting both sides. So that would give us positive and negative 100. Here I'm going to square root both sides. So we'll do square root of 40 in our calculator. Okay, so this is what we call exact form. So 2 root 10 is the exact form. So if a program like Delta Math asks you for exact form, that's what they're talking about. Or you can do approximate form, which will be the most common for us, which is the decimal. So I hit that toggle button, I get 6.3. So most of your homework will ask you to round to the nearest tenth or the nearest hundredth. They'll specify, and they might ask you for exact form on occasion on Delta Math. So this is exact form, and this is approximate or rounded form. And then the third one here, I cannot take the square root of a negative. So we're going to say no solutions. All right, next slide. Here I have a negative in front of both of my terms. So to get rid of this negative, I'm going to divide both sides by -1. So before you square root, you do want your x term to be positive. And then that's going to make this a positive 625. So when I square root both sides, I'll end up with positive and -25. Okay, on this one, I'm going to divide by 49 on both sides to get x squared by itself. So I end up with x squared equals 0. And then square root both sides, I'll get x equals 0. So this is a case where we just have one solution. And then last one for this slide, I'm going to divide by -2 on both sides. So x squared equals 10, and we'll square root 10. So exact form is just root 10. Approximate form is 3.2 if we round to one decimal place. So here's our exact form and our rounded form. Okay, so now we're going to work on some that are a few more steps, because these for the most part were just 1 or 2 steps. Now we'll get into 3 steps it looks like. So first thing I'm going to do here is subtract 4 from both sides. So I have -81 x squared equals -4. Then I'll divide by -81 on both sides. 2 negatives make a positive, so that is now 4 over 81. And then I'll square root both sides. Square root of 4 is 2. Square root of 81 is 9. So we have positive and -2 9s. And I believe I put in your instructions, but I do want you to leave those as fractions if they were fractions as we went along. All right, so here we'll add 10 to both sides. Well, I mean, I want them to be fractions if they're perfect squares. If they're not perfect squares, like 4 and 81 are perfect squares, if they're not perfect squares, you won't be able to write them as fractions, but for the most part, you should be able to. All right, back to this one. So I'm adding 10 to both sides. I have 2x squared equals 74. So then we'll divide by 2. So that should give us 37. So let's see. Did that one earlier, I think. So root 37 is our exact form. 6.1 is our approximate form. All right, and then these are the last couple, but this is where it gets a little bit more challenging for some students because the square is on the outside of a binomial. So before I can move on, since I can't really or I don't really want to distribute, because then I'm going to end up with a middle term, and I don't want a middle term when I'm solving my square roots. I'm going to go ahead and at this point square root to get rid of this piece. So then I have x minus 7 equals positive and negative 1. So at this point, I have to split this into two, where I'll have x minus 7 equals 1 and x minus 7 equals negative 1 to find my two roots. So then here if I add 7, I'll get 8. And here if I add 7, I'll get 6. So my two roots are 8 and 6. So they're not always like positive and negative 3, positive and negative 5. They can be different numbers. So same thing on this one. I'm going to square root at the top. So I'll have 2x plus 1 equals positive and negative 5. And then we'll split into 2. So 2x plus 1 equals 5. And 2x plus 1 equals negative 5. And then you'll subtract 1 and divide by 2. So I get positive 2. And negative 3. All right, that's the end of our notes for today. You do have a Delta Math assignment to work on.